Welcome. Let's solve the following exponential equations. Let's start by looking at example A. Let's start by trying to solve this equation using the same base technique. Would it be possible for us to write down the value of 17 as a base of 3? Let's look at the exponents of 3. 3 raised to the first is 3. 3 to the second, that is 9. And 3 to the third, that is 27. So notice that this value that we were looking for, it is somewhere between 3 to the second and 3 to the third. That is between 9 and 27. So we cannot write down 17 as a base of 3. And when we have the situation, we have a different strategy. We're going to evaluate the left-hand side and the right-hand side by the function of log. So let's do that. If we evaluate the left-hand side by log, then we're going to get log evaluated at 3 to the x, and the right-hand side, we're going to get log evaluated at 17. Now notice where the unknown is. It is an exponent inside a function of log. We have a property that can help us with that, the power rule. The power rule says that anytime we have an exponent inside the function of log, we can always bring it to the front as a multiplication. And that's exactly what we have here. So let's get this exponent of x, and let's bring it to the front of the log in the left-hand side. And now the advantage is that the unknown that we were looking for, now it's been multiplied by some expression, log of 3. So if we want to get rid of that expression that has been multiplied, let's divide it on the left, and let's divide it on the right. And now we have an expression for x. X is equivalent to the log of 17, which is a number, divided by the log of 3, which is another number. Let's find out what that is using our calculator. Now the button of log, we can find it here on the left-hand side. So let's press log of 17, and let's divide it by the log of 3. So now we got our answer. X is equivalent to 2.58. Let's round it to 2 decimal places. Now let's take a look at our second example. Let's start by identifying where the variable is located at. The variable of x, it is the exponent of this second expression that we have here. But notice that this expression is being multiplied by 5 first. If we want to solve for x, we have to isolate the expression that has that variable. So let's try to think of ways to get rid of this 5. Well, since 5 is multiplied, let's do the opposite. Let's divide it by 5 on the left and the right. And let's leave that as a fraction. And notice that now the expression that has the variable that we're looking for, it is isolated. What we want to do next, let's apply the same strategy. Let's evaluate log on the left and the right. And now the advantage of this is that now we can apply the power rule. Let's get the exponent of the inside, and let's bring it to the front. Let's get this 6x, and let's bring it to the front of log. So now we have two expressions in the left. And notice that they are multiplied. So let's eliminate log of 18 so that we can start isolating for x. And the way that we're going to eliminate it is by doing the opposite. If we're multiplying, the opposite is division. So let's divide log of 18 on the left and the right. So we're almost done. Now this variable that we're looking for, which is x, it is still being multiplied by 6. Let's eliminate that 6 by doing the opposite. Let's divide 6 to both sides. And when I'm dividing the whole expression that was already there. Now let's find that value using our calculator. Let's start by finding the whole numerator. So 0.57 is what we have on the numerator. So now let's divide that by 6. So here we have our conclusion. X is equivalent to 0.09. Now let's take a look at our third example. Let's start by identifying where the unknown is, which is the exponent of 16. So if we want to solve for x, we need to isolate the expression that has that exponent. But notice that it's not isolated. We still have this plus 5. So let's get rid of that plus 5 by subtracting on both sides. So now that we have the expression with the variable isolated, let's apply the same strategy. Let's evaluate log on the left and the right. Now let's apply the power rule. Now we can get this exponent of x minus 7, and this whole exponent, we can bring it to the front as a multiplication. So we're getting closer to solving for x. But x, it's inside of an expression that has been multiplied. Well, if we want to isolate that, we need to cancel out log of 16. Let's do that by doing the opposite. It's multiplying, so let's divide by log of 16 on the left and the right. So now we have x minus 7 on the left, and this division of log on the right. Now to get x by itself, we need to get rid of that minus 7. So let's do the opposite, which is addition. So let's add 7 on the left and the right. One thing that I want to point out is that this addition of 7, we're not adding it on the numerator of the fraction that we have. We're adding it as if it was a term of itself. So now let's use our graphing calculator to find this value. Let's do log of 19 divided by log of 16. And now let's add 7. So we have our solution. X is equivalent to 8.06. Now let's take a look at our final example. Let's start by identifying where x is located at. X is located as part of the exponent where the base is e. So let's start by trying to isolate this expression. Let's start by adding 6 to both sides to get rid of that minus 6. And now to isolate this base, we have to eliminate this minus 10. But notice that it's multiplying, so let's do the opposite, which is division. And now that we have isolated the expression that has the unknown of x, which is what we're looking for, we can apply the same rule. We can multiply by log on both sides. But there's something special about this base. This base, it is the Euler number, so we can perform a shortcut. When the base of our exponent, it is the Euler number, instead of evaluating by log on the left and the right, we will evaluate by the natural log. And the reason behind it, it's because the base of ln, it is the Euler number. So let's do that. Let's evaluate ln on the left and the right. But remember that the base of ln is the Euler number. This is where the shortcut will take place. Anytime that the base of the log, it is equivalent to the base of the exponent, they will cancel out. So now we have the expression of 2 minus 2x by itself on the left, and the right hand side, it is ln of 6. And now we can start solving for x. Let's start by subtracting 2 on both sides. And then let's divide by -2. Now let's find this value using our calculator. The button of ln, we can find it here on the left hand side. So let's press ln and let's evaluate by 6. And then let's take away 2. And that number, let's divide by -2. Now we have our result. X is equivalent to 0.10. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.